I began my oncology career by treating and studying patients with acute myeloid leukemia, a very deadly form of cancer. But within a few years, it became apparent to me that in my lifetime, this disease will not be cured. And unfortunately, I was right, because today in 2023, we are giving the same two drugs that we were using to treat acute myeloid leukemia back in 1977. So early in my career, I realized that if we want to cure acute myeloid leukemia, we should be looking for patients who are at risk of developing it, rather than those who have already this frank, widespread leukemic infiltration. Who are those patients who are at risk of developing acute leukemia? Patients with pre-leukemia, also known as myelodysplastic syndromes.
MDS is a disease basically of ineffective hematopoiesis. Very often in these cases, 30%, one-third of the patients that have MDS transform at this stage to acute myeloid leukemia, which at this point it's a very aggressive disease and one that is very hard to treat, is basically non-treatable.
If we are going to study, treat and cure a human disease, we cannot rely on animal models or growing cells in cultures in the labs alone. We need to study human samples. In 1984, I began to save blood, bone marrow aspirates, bone marrow biopsies, saliva, all kinds of samples on my patients. And this tissue repository has evolved over the last 35 plus years into becoming a most precious treasure. We have waited a long time to have the tissue repository on the one hand, or on the other to develop the technology to go and interrogate these samples appropriately. That is the fortunate combination of the two that has happened now and evolved into the Evans P. Foundation MDS Center.
We are capitalizing on a tremendous wealth, diversity, and multidisciplinary expertise of different faculty members. We are also members of the center to look at the disease from all different angles. So here we combine all this expertise and we look at the disease as a whole. And we are focusing on understanding not only how it progresses, but how it is born. We are trying to detect this very first cell, the first that is predisposed, and what predisposes it to become malignant. And from this endeavor, we are trying to really take advantage of all these novel signals that we are isolating them, to target them as a means to interrupt the disease and as a means to overcome the problem of resistance or the development of new clones. We have to be humble, but my hope is that we will be able to suggest at least one or more at least novel approaches for targeting MDS.
We are now at that crossroads where we can finally put into action the combination of all the technology, all the human intellectual resources we have at hand with our tissue repository to help our MDS patients. I think we are at that inflection point, and I hope within the next couple of years, we will start seeing dividends from it.